Hey guys, welcome back to another tutorial. Today we'll be covering the wave function collapse algorithm into a 3D Unity project. I'm going to briefly go over the theory for how we'll be implementing it, but for a really in-depth explanation, I made a video a couple months back that you can watch over here. As always, the project files and the source code will be available through my GitHub, which will be linked in the description of this video. Now before we get into it, if you guys enjoy these tutorials, consider subscribing to the channel to stay up to date with all my videos, and leave a comment down below with what you want to see next. First off, wave function collapse is an algorithm used in procedural generation. It takes a small input pattern and efficiently generates larger coherent structures while respecting certain constraints. For this tutorial, we will need the following things downloaded: Unity 3D, any version should be okay, but I recommend any of the LTS versions. Any script editor of your choice, I'll be using Visual Studio Community, the tweening package, and some 3D models. The ones I've used I created in Magica Voxel, but feel free to use your own style of prefabs. The ones included in this video will also be included in the downloadable package of this project. Now, although this project is in 3D, the best way to visualize this is actually in 2D, because what we're doing is creating a grid and transforming that into 3D space. I'll create a visualization of our steps that will follow into code, but feel free to experiment with the specifics of this. For this example, I will have a few building variations and a simple road set with these variations. We'll first predefine which tiles can go next to each other. This will be done by adding each prefab to a list of up, down, left, and right neighbors. For this example, I'll keep it simple and say that buildings will be able to connect to all other buildings in any direction, but they can only connect to roads that don't lead into them. So take this corner road piece for example. The up neighbor can be every building piece, and for every building piece we can say that the down neighbor will be the corner road piece. Once we've defined every tile variation, we should get something that looks like this. Now we can actually get into the wave function algorithm of this project. We'll start by initializing our grid to whatever dimensions we want, and we'll say that any position could be any possible tile. Again, if you want specific positions to be specific tiles, say at the edge here you don't want the roads or you don't want the buildings, you can define that in this part here, which in pseudocode will look something like this. So normally we will look for the grid position with the lowest amount of possible tiles and prioritize collapsing that first. However, our first piece we can start completely randomly. So we will collapse that piece and then based on what tile that is, update the neighbors around it. This is sort of through a process of elimination. We'll essentially compare the neighbors list with the piece that we just placed so that the neighbors' valid pieces coincide with the tile that we've placed. Now, once all neighbors have been updated, we start the loop again. And usually by this point we'll have a grid position that actually has a lower tile possibility, so we prioritize collapsing that one first. Again, we've collapsed it, and we'll update the neighbors in the process until we have our fully generated map. Now, let's jump into the editor and get coding.
Hey guys, so I have just booted up a new Unity project. This one I've pretty much just created a flat plane 3D object here, and I've imported all of the 3D models that I am going to use to create this. As you can see, I've just got them in the background for now. This is just to sort of showcase what models we'll be using. We don't have to use all of them, but I'll probably use all of these. Now the final thing that we want is inside of the asset store, or rather the package manager. We want to make sure that we've got the DoTween installed. Now this part is pretty optional, so once you see the DoTween step, you can skip that if you're not going to use it. So let's jump straight into this. Once we have all of our models set up like this, we do want to create like a prefab of each of them. This way it's just a lot easier to keep track of. And the first thing that we're going to do is start creating our scripts. So I have a scripts folder here, and I will create our first script called tile. Okay, so with this we can actually remove all of the default methods. And what the tile class contains is the different list of neighbors. So they will look like this. Now back inside of our Unity project. And I will disable all of the default prefabs for now. And inside of our prefabs folder with all of the objects selected, we want to add the tile class to them. Now, this part will be a little bit time consuming. This is kind of like the chunk of it. This is where we're going to be setting up each instance of the up, right, down, and left neighbors. So I will do that and I'll catch you guys in a second. Okay, so I have just gone through every single one of these prefabs and given each of them their own neighbors. I will say that I have created my own sort of constraints as well, so certain tiles can't connect into each other, or two tiles of the same type can't connect back to each other. But once we have that set up, we can actually get into the next part of the code, which will be our cell script. And inside of the cell script, it will be nice and simple. We'll have a public bool called collapsed, and a public tile list for the tile options. Inside of here, we'll create two methods, create cell and recreate cell. Now, once we have written up our cell script, we will create a new empty game object that we can just call cell. We can reset the transform, and we'll just attach the cells class to this object now. Now it might be a good idea to just drag the cell back into the prefab list as well, and you can delete it from the main scene. Now, we will start writing up our next script, but before that, we can actually create our wave function generator object. Again, we can reset the transform for that. We'll go back into our scripts folder, and we can finally create our wave function collapse script. So we'll just get rid of the default methods here, and we'll create our own sort of properties to begin with. Now, back inside of Unity, inside of the wave function generator object that we created, we can actually add in the wave function collapse script. Now, where it says cell object, we can actually go into our prefabs list and drag in our cell object. Now, we can also fill up the tiles property, so I'll just lock this really quick. And I'll drag in all of our tile variations here as well. Just like that. So we will open up our wave function collapse script again, and we will start defining all of the different methods. Okay, so we have just written up the different methods that we'll be using. Everything obviously starts in awake, and we will first just define the grid and basically populate that to be all of the possible tiles. So once we've got this initialize grid method called, what we can do is actually go back into our Unity project. And what we'll do is with the cell prefab, unlock this, is we'll give it a tag just so we can actually see it inside of the scene view. So when we hit play now, although obviously nothing will happen just yet, we turn on our gizmos, and we find our wave function generator. Oh, still got the dimension set to 0. Let me just set that to 20. There we go. So now we can actually, let's move the camera. So we'll align it here. Look, there we go. So now we can start to see everything generating. So these are going to be like basically every place that the tiles will generate to. So you can see here, if we look through all the list objects, they currently completely populated with every possible list. Now the next step will be to basically update this list procedurally. So let's get back into our script and keep coding. So the first method inside of the wave function collapse, method, that is the check entropy. And basically this is just going to organize the list so that the first element will always be the item with the sort of lowest variations possible. So the method will look something like this. Essentially, yeah, like I said, it's just organizing the list so that the first element that appears is going to be the item with the lowest entropy. Now, at the end of the initialize grid, we want to also make sure that we are calling this as well. Now, the next thing is to actually collapse the cell, meaning basically put the actual tile into this cell's position. Okay, so we are finding a random tile, and basically what we're doing is we're filtering the list of possibilities. So we're assuming that the list is greater than 0, and we're grabbing a random tile from its list that's left inside of that cell, and then we're instantiating that specific instance of the tile. The next thing that we want to do is, based off of that specific instance of the tile, we want to update its neighbors, and we want to make sure that we're doing this according to the already existing cell list. So we will call the update generation here. Now the update generation is kind of doing two things here. It's updating what possible cells or what possible tiles are left here, but it's also validating that they can exist there. So there will be two methods here. So we'll have this list here, which will be a sort of copy of the existing grid components list. That way we can touch it without actually breaking it. And then we are going to loop through the dimensions again. And this time we'll use a sort of little hack way to get the index of the element inside of a specific position, and then compare it, check whether it's collapsed already, and if it's not, if it's being collapsed, what needs to change from it. Okay, so this is sort of the main setup here. Just make sure that you have added in the arguments into the check validity method as well. But essentially, the overall method here is going to look very similar. We're going to have to do a check for the up neighbors, the right neighbors, the down neighbors, and the left neighbors. And once we've done all of those, then we can update the overall generation. So there will be four sort of different statements here that will look similar, but they're all checking, the different directions here. So we will be using an extra library here just to make sort of the calculations a little bit easier, but this should come already with, I guess, all Visual Studio or like C#. Just to make sure that you include these two packages at the top here. Alright, let's get back into it. So when we're looking up, we want to look at the down neighbors. It's sort of in reverse. It's the same as when we're looking right, we want to get the left neighbors, left to get the right neighbors. Now, the check validity method will look like this. Now, essentially what we've done is we're creating two lists here, the existing list and the updated valid options list. And if anything inside of the valid options list isn't inside of the options list, then it's going to remove it. That way, all of the tiles will always be completely correct. So I'm sure you can already tell these two are looking very similar, and it's completely right because we're doing one for the up, we do it for the left, down, and right, and they will be sort of similar, but the only thing that we're looking at differently is the cell position. So what we can do to actually make this a bit easier is we can copy and paste this, make sure it's copied 4 times, so 1, 2, 3, and 4, and we'll just update the if conditions here. So this one will be for down. We want to update the cell name and the grid components here. Make sure this name is copied over as well, and we want to make sure that the valid check here is looking at the correct neighbor, so this one will be the up neighbor. Now finally we'll do the same thing again for the left here, or for the right, sorry. There's one more thing that we need to do, and that's going to be to update the actual grid components list, and we can increase our iterations count and restart the generation.
So if you missed it during the coding there, the valid option should also check, it shouldn't actually just be a valid option or contains, it should do the false check at the front here. So once we get that running, and we can hit play. Now you notice we can run into an error here, and that's the case of where we've run into a case where there's no possible tiles left. And what we can do in that case is actually create a backup tile. Now inside of the collapse cell method here, we'll do it as a try-catch block. In the case that it gives us an exception, instead we'll just output something else. Now if we go back into our Unity project, the backup tile that we will define, I'm just going to set it to a random building. Hit save. So now what will happen is it'll just give us a random building instead, whenever there's an error. Alright, so there you go. So obviously I went a little bit overkill on the entire sort of tiles here, or like the actual road generation, I suppose, and again, feel free to play around with this exactly as you like. There is a couple other changes that we'll just make here. So first off, do have a argument out of range exception. If you recall, I did say we will be increasing the iterations count during the entropy check, so that will look something like this. So now the iterations will always cap out once we've exceeded the dimensions. Now, finally, the optional step that we were going to create is using the DG tweening package. So you'll include something inside the tile class that looks like this. Perfect, that's all we'll need for that, and we can just go straight back into the Unity project and we can just run it as normal. And this just gives us a nice little effect for when the tiles are being placed. Well, I hope you guys enjoyed this video. I hope that it was very easy to understand and that you guys get something valuable out of it and hopefully make some cool creations of your own. If you want to see any other tutorials, do let me know in the comments below. I'll be happy to keep working on more. But yeah, otherwise I hope I will see you guys in another video soon. Take care.